A while ago now, I get this new set of Forstner bits to replace my current ones. Unfortunately though, I can't use the same holder because the new ones have a hexagonal shank which is a bit bigger than the round shank from the old ones. So I have to make a new one. I can reuse the backplate of it and only have to make this one new. And if I make it exactly the same, then I can still use this plate here which has all the sizes on it. And it happens that I still have the same piece from which I made the old holder. It has already the right size, so I just need to cut off a strip from that. So the 50mm bit was about here and the 10mm bit about here. I had about 6mm of space between the back edge and the drill bit, and that was pretty good, so I will do that again. To save a little bit of time, I'm just going to eyeball transfer all the other hole positions as well, so I don't have to lay out all the bits right here and figure out this layout once again. Now I can use each individual bit itself, line it up with this line and the 6mm spacing line in the back, and mark the hole position.
There's also about 6mm space between each bit. That's how I figured out this layout in first place.
On the old holder I also drilled a very shallow hole with every size, so when you put a bit back and I'm not quite sure about the size, then you can just hold it there and see if it's correct, but I've never used that once. For the 6 bigger bits it was as simple as drilling a hole all the way through, but for the smaller bits that doesn't work because the shaft has the same size as the hexagonal part. So to make that work I set a depth stop on the drill press and I drill the rest with a smaller bit. And now the rest for the smaller bits, but they also have smaller hexagonal shanks. The reason for drilling the holes all the way through is that dust can never plug up the holes. So you can always just put the bit in there, because dust that might accumulate here can always fall through. And finally the holes for the hole saws. Alright, everything at its place again. In hindsight, I think it would have looked better if these ones also would be at that height, but doesn't really matter that much. And because I know that some of you will be interested in these bits, I put a link to where I bought them in the video description. They cost about 300 euros and these I think about 40 or 50. So what is the difference between these two prices? So I got a piece of ash hardwood here and I'm trying to drill a 25mm hole by hand with the old bit. As you can see, I have to use my shoulder and my whole body weight, or hold with the other hand on the table to get something out of it. And a big drill. So let's test the other bit. And I think the little drill is enough. As you can see, this is the difference. Even with the small drill in second gear and much less effort, a 25mm hole is totally possible. And now another piece of hardwood and the 50mm bit in the drill press. Do I even have to say something about this? That's what you're paying for. And also, the bits don't get very hot. That's just after drilling, and it's only a little bit warm. Easy to touch. But why the hell do such demonstrations always have to make such a mess? Also, I can only recommend writing the sizes directly behind the bits and the hole saws. Best upgrade since I made this holder. Then a few months back I had a low angle jack plane on my Amazon wishlist, and then somebody emailed me saying, "The one you chose isn't really that good, I'll get you a better one." And a few weeks later this arrived in the mail. A Lie-Nielsen low angle jack plane. Very cool. A big thanks once again. Nice maple shaving. It's been sitting here all the time. It also really needs a holder to go right about here on the wall. Scrap piece of plywood and beech hardwood should be enough.
Unfortunately, my microphone battery died right here and there are a few clips without audio. But after screwing the two pieces together, I made them straight with the plane, drilled the holes so they had exactly the same place, and then cut them out. The screws end up on the offcut pieces. And to center pieces evenly afterwards, I lined them up again with the drill bits with which I drilled the holes. I also went with a nice piece of beech for the backer board instead of plywood.
The distance is the width of the plane plus the thickness of this triangle, so there's enough room for wood movement and the finish.
And using the drill bit again to line the two pieces up.
Now it works, but not quite as good as I expected. So putting it in is pretty simple and works great, but getting it out there, it often ends up jamming under the front pins, and yeah, then you struggle a little bit getting it out. I guess the problem is that I have to slide it front, or when it's on the wall, up by this far, and only then I can lift it up and get it out. If I only had to slide it out this far, that would be enough to clear the edges, then the problem with jamming wouldn't be quite as bad. So I think I just cut a little bit off of this dowel here. Okay, I've done that and a little bit more. I've cut a little bit off of the dowels here and added this stop pin. The cutout in the back now allows to lift it up earlier. The pin in the front stops it from being moved too far under the pins and might get jammed. And by cutting away a little bit of the pins, I can tilt it more. And now it should work fine. A little bit more complicated than I first thought, but that's how it is sometimes. That works great. I also never have to worry about the blade because the plane naturally tips back a little bit. And here again with 2 coats of water-based polyurethane. Moving on to this. That I already posted on Instagram. Banggood.com offered me to choose one item from their website that I could use in a project. So I chose this variable frequency drive. And as you can see, it's working. don't worry about this shaft key. This won't come out. I can hit it with a hammer. It's pretty rusted in there right now.
I also tried to filter the high-pitched noise coming from the carrier frequency of the VFD. It's actually much louder. If you want to hear the actual noise, it's in the outtakes at the end of the video.
This VFD needs a 3-phase input, and that's what I have wired up here. So on Instagram I already asked where I should use it. I have two options, the bandsaw which already runs on 3-phase and the dust collector which already runs on 3-phase. The table saw also runs on 3-phase, but for the table saw it doesn't make any sense. So bandsaw or dust collector? For the dust collector I could somehow automate the system. So for example, when I open a blast gate, that would activate a little switch and then turns on the dust collector. I could also let it spin up slowly and make it break after I turn it off so it stops more quickly. All the nice things you can do with a VFD. But that would require quite a bit of effort because building all new blast gates, to include this, all the wiring, and quite more time consuming than the bandsaw. For the bandsaw I would use it so that it would start slowly, I demonstrate that in a second, and make it stop quickly when I turn it off. And also I could regulate the speed. Right now the motor starts really aggressively and it does this every time I switch it on. Nothing if you don't plug it in. It does this all the time. Installing it on the bandsaw wouldn't be that time consuming, just building the new switch box with new switches and the knob to regulate the speed. Yeah, that would be it. So whatever you think, you can vote somewhere up there in the video or comment. Oh yeah, and if you have more interest in this unit, I posted a link to it in the description, of course. And now finally, it very often seems that when I'm reading through my comments that you are very interested in a shop tour of my shop. I'm sorry, but no shop tour now. But you also very often ask for specific parts of my shop, so I thought, no, why not show the most recent addition? Which would be the stationary compressed air in both shops. So in the woodworking shop, with the hose reel, a very cheap one. This one goes with a flexible tube over the dust collection piping, over the clamp rack, right down here, out of the shop, and then comes out here, down to the compressor. Now in the other room at the metal lathe, we first of all needed more lighting, which we installed here, and also more power. So now the lathe has its own circuit and breaker, and it's fully independent of the lighting and the other plugs. That's what we wanted and needed. And while we were at it, we also installed the compressed air here, because you always need compressed air at the lathe. Goes up here parallel to the electricity around this corner, here, and then through this wall. Comes out of the other side of the wall behind these boxes. Here, then here, over our skis, and again down to the compressor. When we installed the compressed air, our main requirement actually was the electricity for the lathe. And for the electricity, there are these tubes and the clips. You can just buy them in the hardware store. And the cool thing with these clips is that they always have little hooks, so you can hook two of them together without needing an additional screw. And so you can easily put two lines of electricity next to each other, or in this case, compressed air. Except that it didn't fit. So therefore, I then custom 3D printed these little clips that go inside the big clips, and they then fit the tube for the air. And we did this pretty much everywhere. Quite a few clips, also some more special ones. So this one just hooks onto the tube and the other end fits the air tube, and also the same basically everywhere until it was where we needed it. For the woodworking shop I have OSB walls, and so I just made my own screw-in clips. A closer look to one that's left over. Pretty simple to print. Not much to it. And for the connection, I made a big, very custom clip that hooks over all of this. That was quite difficult to draw in 3D. And that's what we use 3D printing for really useful stuff that you can't buy or get on other ways. And before you ask which 3D printer we have, that doesn't really matter because such parts are so simple, any 3D printer can make these. But one word about this compressor, because I think this could be really interesting for some of you. First of all, it's one of those silent compressors. So you can still talk comfortably next to it while it's running, no problem, very comfortable. It has a 50-liter tank, its own water filter and 2 outlets, which is so cool. And the best thing is, I think we only paid 350 or 400 or something in between that for it, which is very cheap for one of those silent compressors with this size tank. And yes, of course, you can find a link to it in the video description. And no, what I said was not sponsored. That was my honest opinion, if you couldn't already hear that. We have this compressor for, I think, more than half a year now, and really like it. One of the best cheaper tools we've ever bought, well worth its money. And that's it for now. Okay. And I think goes parallel with the electricity in an unsharp picture. The cool thing with these clips is that you can put 2 of them together next to each other